Yeah.
Okay, fine. So just going to presentation mode. So welcome again all Foundrymen. Sandeep, please let me know if I am not audible. So
Yeah, you're
welcome,
audible. You can go ahead.
yeah, welcome Foundrymen again on this forum. And my today's topic, since Mr. DG Gaikwad has explained about the metallurgical aspect of the inoculants and all, I would like to focus more on the application and the performance part of the inoculant, which is more important for the foundrymen when they are looking this inoculant from the application and performance perspective. So before we go into that, as I said, many thanks to TFG and Sandeep and all foundrymen. And since Sandeep also said in the beginning, 3 or 4 of the major suppliers of the inoculants are present in the forum. So my request to all the foundrymen, please change your mindset. The suppliers or your raw material who are supplying to you, brands, they are not your supplier. Consider them as a partner. The moment you change your mindset from supplier to partner, you will start reaping the benefits of mindset itself. Because if you think as a supplier, you will always try to blame them for quality, problems, rate and all. But if you start thinking from the perspective of partner, definitely they will be a part of your solution because they know their part in a very different way and they are the domain expertise about those things. So they are in a better position to guide you. Sandeep, you can correct me if I'm wrong.
No, Manish, you're very much true. We
Okay,
should
so
understand as a
question
partner.
to, yeah, question to all of them or as a group. So question to Sandeep indirectly. So what is the difficult challenge for speaker in evening Foundry webinar? Sandeep has to answer.
Yeah, to focus properly, it's a big challenge because after a whole hard day, you have to focus and give attention.
Yeah. So this is the problem with the technical guys, you know. Now I would
Yeah.
give you a very simple answer. So this is a simple answer for that question. No tea, cold drinks. Because this is a very common thing. Whenever we are going to ask a question or something in a foundry forum or a technical guys, they are starting us thinking of very simple question in a very technical way. Anyway, skipping this thing, for my webinar, I would like to take this in a more of a humor way rather than a very serious topic, because I know inoculation, metallurgy, these things are very serious topics. So my suggestion again, uh, don't try to sleep in my forum at least for 15 minutes. If you ask questions, then zero effect, there means no effect of my presentation. Secondly, I am here not to present MPM's product, and please do not ask any questions or anything related to company, or don't relate any issues or any positive trends or even achievements with the MPM or my company over here. It's a different forum. We are completely on a technical forum. Right, Sandeep? Okay.
Very true, sir.
So index, I'm going to present in next 10 minutes about the philosophy of making casting, why inoculant, fading and effect on micro, inoculation process, inoculant types and elements, elemental effect with the case study for rejection and machinability, tips and conclusion. So starting with the presentation, as I initiated a move from 2007 about the zero rejection concept in the foundry. So I would like to say few words or few slides with the zero rejection again, because that's the philosophy of making casting. And then I will be moving to the core topic. I will not take more than 10 minutes. I will be 100% within the time limit. So the question is, when you have a zero rejection in foundry, Sandeep, answer is with you.
Yeah, when all the things are as per your specification or whatever process you are defined If you follow it, you will have been almost near to zero reaction.
Fantastic answer. Again, a very good technical answer. And again, not the simple one. The best answer for this is when foundry is closed, you have a zero rejection. Next slide. Anyway, so okay, so we will go to the philosophy of making casting. What is the philosophy? You know, whenever if you believe when 98% of the casting defects occur when the metal is molten, we all know when metal is molten, then only defects occur. So in an ideal world of perfect mold, if we make a perfect mold and a perfect melting, if our pouring time is 0, if ingot velocity is 0, if solidification time is 0, then there is no time for defects. This is a philosophy of making the casting, which is again what Sandeep was trying to say in a very normal words. I have said this from the metallurgical point of view in a technical word. You can imagine if pouring time 0, ingot velocity 0, solidification time 0, there is no time for defects. So what does that mean? That means it is giving you a direction. Whenever you are going in a green direction, whenever your pouring time is less, whenever your ingot velocity is less, whenever your solidification time is less, that gives you there is no time for defects. It means it will give you a lesser defects. If you move opposite to the direction which is here in a red arrow, that is the point where you will go in the direction of the defect. So this is actually a philosophy of making the casting, right? So in short, whenever there is we are going towards a zero defect, if you use less of everything, like I have said in the previous slide, you are going towards a zero defect concept. So this is a philosophy of making casting, which I am promoting right from 2007. That's why I'm shared this 2 minutes with the slide. Now we are going further for the detailed topic. So coming to the inoculation topic, I urge all foundrymen, whenever they are looking inoculation or inoculant as anything which will do a magic, please remove this from your mind, because using special inoculant like cerium, like bismuth, or like strontium, zirconium is not answer for your any issues. It is the last solution. As DG has already said in his presentation earlier, casting profile, cooling time, solidification, basic recipe, grade, chemistry, charging material, pouring temperature, trace elements, nucleation potential, superheating, limitations of infrastructure, molding media, hypereutectic combination, everything, methoding, tooling, and flow of metal, which is again a DMA. I was always trying, people are asking me, sir, inoculation का कुछ है क्या आपके पास में? Because I am getting a shrinkage. अच्छा सर, आपने क्या check किया? सर नहीं, लेकिन shrinkage आ रहा है. We have also faced the similar question in the groups. I am getting shrinkage. Can you suggest inoculant? It's a very generous question, boss. You have to look into those all parameters first, getting, methoding and all. Ultimate answer, if nothing is there, then only 1% is a possibility where inoculation can add something into the performance. If you have a direct shrinkage, believe me, 99% inoculant will be not work. If you have a micro shrinkage, very, very minute, some because of the fading or something issues, then yes, that's an answer. So what exactly is the inoculant? If you see first, second, third, these are the chill, wet chill test. If you see in a first, there is no inoculation. Second with 0.25 ferrosilicon, third with 0.125 SR. So these are the elemental effect. I have not used anybody's product here because this is a forum of a technical forum. So I am trying to give elemental effect. So if you see in a first slide, you always, you having a higher chilling tendency. In a second slide, because of using ferrosilicon, you have a lower chilling tendency. And a third slide, in a third chill, you can see because of using the strontium based inoculant, you have a very less chilling tendency. So this is already shown by Mr. Gaikwad. You can see in the left hand side, the effect of uninoculated microstructure, and for the first one is a gray ion and second one is the ductile ion. So in first one you can see the carbide formation, and in a second one you can see the better microstructure for the gray ion as well as the SG ion. Okay. So this is the effect on the mechanical properties. Earlier we have seen in the microstructure. Now this is the effect on the mechanical properties, because the inoculation also improving the mechanical properties. So if you can see in the first and second, it will improve the tensile, it will improve the elongation, and will also improve the hardness with the improvement in the microstructure. So this is the fading effect of the microstructure. Holding time versus inclusion numbers. Then this is a fading effect on the microstructure. What exactly is a type A, type C, type D, and E? Mr. Gaikwad has already expressed this in his earlier slides, so I will not spend much time on these slides. So this is what he has already shared. First one is a lateral transfer, second is the lateral transfer, and third one is a mold stream inoculation. So this is a normal practice. I would suggest everyone has to establish their own numbers, but whenever somebody is saying the ladder grade inoculants, the ladder grade inoculants are ranging from 0.5 to 2 mm, 1 to 3 mm, 2 to 6 mm. So there are some always questions people are asking, what ladle is the best? What sizes are the best for the sizes of the ladle? So this is in general. Everybody has to set their own parameters, because no foundry is similar, even though they are producing the identical component. So for the greater than 50 kg ladle and lesser than 300 kg ladle, we can use 1 to 3 and 0.5 to 2 mm inoculants. For greater than 300 kg ladles, 2 to 6 mm, and for greater than 1 ton, 2 ton, 4 to 8, 8 to 12 mm, these sizes are recommended. Then for mold stream inoculation, 0.2 to 0.7 is advisable, and in mold inoculation, and there are inserts available for the bigger castings. But usually for the pouring, where pouring machines are there and auto pour systems are there, 0.2 to 0.7 mm is the normal recommended size. What are the inoculant types, elements? So there are two types of inoculants. I'm telling you from the manufacturing perspective, not the elemental. There are two types. One is cast and another one is mixed. However, nowadays mixed inoculant is outdated. So most of the inoculants are already exist are cast inoculants, and they are classified as potency. So there are low potent inoculant, medium potent inoculant, and high potent inoculant. The potency actually is the intensity of the element. So low potent is a ferrosilicon with calcium aluminum. Actually, all inoculants are having a ferrosilicon with calcium and aluminum. Then medium potent is a barium-based inoculant. High potent is the strontium, zirconium, cerium, bismuth, lanthanum, antimony, because these are very specific and very strong inoculants where you need a specific purpose to use it. Otherwise, even an extra dose of these inoculants will give you the defect. So these are something which we are trying to conclude the effects of the element. So if you can see the fifth number, barium containing Fe is having the highest fading tendency. So this is a chart where you can decide what exactly you want for the element and what exactly will be the effect. So in left hand side, you can see the nodules per mm square, and in x-axis, you can see the time after the time for the inoculation after pouring. So this fifth number, you can see having the maximum time up to 20 minutes, which is a high barium inoculant. Say for an example, if I take barium, so it is having initial, say for example, 7th. So 7th is a strontium. The initial effect will be highest, but it will start fading after 10th minute. Even for the bismuth, if you can see, if I, there is no, okay, there is no bismuth over here. It is in the next slide. So if you see the 2 to 6 minutes, these are the minutes where you will have an initial graphite precipitation is very high, and then it will start slowly fading. So barium is the highest fading tendency as per the number 5 chart. So if we see specifically in barium, it's a fade resistant inoculant. It is mainly used in gray and ductile iron commonly. It's used at heavy section thickness also with a high pouring time, positive effect on slag formation in ductile iron, effective inoculant for alloy ions such as resist, especially effective as a preconditioner or as a first step inoculation. So this is the elements and their effects we are starting for. So I am taking a strontium. Generally, it is supposed to be admitted that strontium inoculants are supposed to be best for gray iron, even though the strontium inoculants are also being used for SGI. It's a myth in India that strontium inoculants are only used for a gray iron. No, strontium inoculants are also used for the SGI. For your information, the most of the foundries which are producing these piston rings, the piston ring foundries which are having only 1 or 2 section thickness, they are also using strontium based inoculant for SGI. So it is not the strontium is only used for the gray iron. It is also effective for the SGI. So this gives maximum chill reduction. It promotes less shrinkage than other inoculants. It reduces the chilling tendency, and it is also improving the microstructure. So here is just a casting which I am shown. We have taken some study with those casting where in the this region, if you see the fin region over here, they were having the D-type casting formation, and they were using barium based inoculant over here. But with use of strontium based inoculant, the shrinkage tendency and the machinability has improved over here, which has also improved them to improve the machining. So strontium plus zirconium. So this is the, I'm trying to show from the case study perspective. So this is the RA housing where earlier they were having C-type defect in the microstructure, which has improved with the help of strontium and zirconium. This is also the similar defect where they have a C-type and open grain structure after machining, if you can see in left. But while using strontium zirconium inoculant, we have able to eliminate this defect. So again, I would like to declare here, it is not the ready-made solution. Only just by using inoculant, this everything has gone. You also need to work on gating, risering, plus fading, plus chemistry, and the molding media and the solidification things. So it is not the magic that you will drop the inoculant and things will go. No. Cerium. So cerium is again, we are using as a high potent inoculant. So cerium, like gray iron is supposed to be have a better inoculation. Cerium or RE based inoculants are supposed to be better for the SG iron because they are actually used to reduce the shrinkage defect. It's just like a strontium effect in a gray iron. SG iron for SG iron, cerium is doing the same thing and also helping to reduce the tramp element. Sandeep, I hope I am in time.
Yes, you continue. There is no such time limit. You can continue.
No, no, but I just wanted to finish in 10 minutes, whatever my time.
No problem. Given. No problem.
So bismuth and RE over cerium. So there is again myth in India that bismuth inoculants are promoting the elemental effect and they are promoting the cumulative effect in the casting as the residential element, and later on when it built up in the RR, it is giving the defect. No. If you are using direct bismuth as a metal, then there are chances of building of bismuth inoculant, bismuth metal or bismuth element in the RR or the casting. But if you are using a bismuth with a combination of the RE, it is like a poison because using direct bismuth is a poison for metal. But when you are using bismuth plus combination of RE, then it is acting as just like a poison curer. if it will give you a better effect in terms of all elements. Like in the left hand side, you can see if you use ferrosilicon, if you use cerium base, your initial graphite precipitation in left hand side, if your nodal count is 100, and with the cerium, if your nodal count is RE based inoculant, you will be having 350. So which is almost 3 times, but it has to be used in a proper way. So bismuth is not harmful for the inoculant. In fact, for the higher section thickness casting, if you started using higher RE magnesium plus higher RE inoculants or only cerium based inoculant, you may land up with the chunky graphite defect, which is very difficult to remove further. This is specifically for the heavy section thickness. Okay, so this is for the elemental effect. So what is ongoing trends? For shrinkage reduction, longer fading FSM. Now the ongoing trends are lanthanum based FESIMG, lanthanum based inoculants, antimony based inoculant. Some foundries are using preconditioner, but it's again a question whether they need a preconditioner or not. Because earlier days when there was no, peoples were not using the pig iron, definitely people were looking for the preconditioner because of some added advantage, but it has to be evaluated and re-evaluated whether we really need a preconditioner or not. So this is the topic. I'm over for the inoculant, but I would like to focus what I'm trying to say before you come to a conclusion. What is the defect and what is the effect and what needs to be done? Please follow this process. Take a photo of the picture, examine with a magnifying glass, then examine with a microscope, 500x, 100x, 200x, 2000x if it is possible. Do a SEM if it is required. Map the process and then record and then graph. So these are the actual process you should follow before reporting any defects either in the group or even solving in a foundry. And then benchmark your defects or everything with the spectro, softwares or anything, whatever is a benchmark available to you. So conclusion, what type of defects are possible to be cured by inoculants? Again, if you are already 95% done with your chemistry, your microstructure, your methoding, your getting and everything, then these are to be considered. Carbide reduction can be reduced by inoculants, D-type or undercooling, nitrogen fissures, micro shrinkage, microporosity, revergent defect. The revergent defect is the defect when you have on the mold, on the casting wall, on the side of the mold, if you have SG iron producing and the flakes are coming in the SG iron on the wall of the casting, which is facing to the mold, then that is called the revergent defect. It is possible to reduce by using cerium based inoculants. Nodularity and nodal count issues, like I said, for the bismuth. If you want a booster, you can improve with the bismuth RE based inoculant. Matrix perlite ferrite issues, uneven hardness elongation, machinability, these can be improved. And trace elements like vanadium, nitrogen, phosphorus, tungsten, lead can be some extent, not higher, some extent can be reduced. Follow this less is best philosophy. Base has to be good. Your base has to be good. Man, machine, material, and method has to be the base for making inoculation decision. Then, as I said in the graph, in the picture, systematic approach for defect solving, Gemba, Magnify, Micro, SCM, RCA. Make sure your own process is robust, because 99% time we have found the problem is in the process, not in the raw material. Believe your process, inspect, and then look into raw materials. Make your foundry process system driven. Good maintenance, raw metal selection, and careful metal handling are the 3 key criteria in the metal defect control. And high potent inoculant will save machining cost. Don't only look into the price. Please I am again urging everyone, whenever you are looking to any special material, it is not only inoculant. Whenever you are looking for any special material, don't ask first question as a price. Ask question to the supplier or your partner. What are the different types of advantage it is going to give if I am paying a higher price? This should be a way of asking the question, not कितने में मिलता है या कितना देती है. So avoid superheating and holding of the metal. Be receptive, open and transparent, because we have seen in most of the foundries, whenever you ask for any question, sir, this is the problem, I think there is a process issue. So first foundryman will say, अरे यार मैं 100 साल से यही कर रहा हूँ, यही मेरा प्रोसेस है, अभी तक डिफेक्ट नहीं आया, अभी आ गया. So please believe us, if you are doing a wrong thing from 100 years, it cannot be right. If it is a wrong, it is a wrong, whether it's 100 year or 50 years or 10 years. You have to do it right whenever you come to know. So be transparent, discuss for a change. And with this, thanks to Foundryman, thanks to Sandeep, and thanks to all the group for giving me a chance and opportunity for this presentation. Over to you, Sandeep.
Thank you, Manish. Thank you very much. It was a very interactive and very informative session as usual from you. So thank you. Question answers we'll take at the end.
Yeah.
Yeah. Okay. And now we request Mr. Kumar Kisloy of Elchem India to start his presentation. Welcome, sir. You can share your.
Yeah, so I'll just share. Yes. I just want to start with wish evening to all the who are present in the webinar. Thank you for joining. First information, you were supposed to have Akshay for this session, but he has some personal emergency because he could not attend. Everything